Okay, so we're going to think about functions in just one other way. I mean, we're still talking about the same description of a function here, but I'm just going to present it to you in another way that hopefully makes it even more understandable. Right? We've looked at a graphical representation, we've looked at the vertical line test. Now I want you to think of functions in another way. I want you to think of them as a machine. Okay? Here's my function machine. Okay? Sometimes math teachers make students make these projects where they make a function machine where you have an input, you can drop something in, and then it'll go and whir and spin and buzz and hiss, and then out plops. Should use a different word other than plop. Out comes another number. Okay? No, unless you really beg me to, I guess. So we're gonna. I know this is kind of just a paper representation of a machine, but I'm gonna show you how this machine works. Okay? We're gonna input a number for x. Okay? We're just gonna choose a number at random. We're gonna run it through the function and see what the output is. Okay? So somebody give me a number, a positive whole number.
8.
8. Okay. So we're gonna put x equals 8. So we're gonna drop that into the function. Okay, into the function machine. That's the input. All right. So that 8 is going to travel. Watch this. I can move it. Oh, hold on. That 8 is going to travel through our machine. I love this little doodad. Okay, it goes through here, and it buzzes and spins and goes through our machine, and eventually goes into this function where it replaces this x with the value 8. Right? I put in 8 for x. So what happens when I put in 8 for x? What would the value of y be when I put in 8 for x? Well, we can just calculate that, right? Put that back up there. We can just calculate that. Y equals 2 times 8 plus 5. That's 16 plus 5, which is 21. Right? So after I put in 8 and it goes through my function machine, out comes 21. Okay, out plops 21. Follow the idea there? Okay. Is there any other number that could have come out other than 21? Is there any other way I could have done this calculation so that something other than 21 could have came out?
Change either the 2 or 5.
I can't change anything about the function.
Just change the value of x.
Other than changing the value of x. If x is 8, is there any way of doing this calculation? Is there any other way of doing this calculation so that I get something other than 21? No, it's impossible. Right? If I put in x, or if I put in 8 for x, I have to go 2 times 8, which is 16, and then I have to add 5. And I will get 21, and I will get nothing else. So if I did this again, if I put in 8 again, let's just try. Maybe something different will happen. Okay, if I put in 8 again for x. Okay, so that means I put in 8 for x in the equation. Will I get something different this time?
No.
No. Are you sure? It's just 16 plus 5. Did the laws of math just somehow change? No. Okay, this still equals 21. Right? So no matter how many times I put in 8 for x, I will always get 21. That's called a one-to-one correspondence between 8 and 21. You could say 8 and 21 are dating, if you want to use the dating example. 8 would be the guy, 21 would be the girl. With me? And no matter how many times I put that 8 in, I will always get 21. That's what a function is. Every single time I put in a value for x, I get its tied to value for y and nothing else. If I put in a different value for x, somebody else give me another number.
31.
31. Okay, I put in 31 for x. That means I just put in 31 for x in my equation. That gives me 62 plus 5 is 67. Right? If I put in 31 again and ran it through, would I get anything else? No, it wouldn't make sense, right? So, on that basis, we can say that 31 and 67 have a one-to-one correspondence. They are tied to each other. 31 cannot produce anything but 67. Now, there are some relations that could produce multiple numbers. Okay, you start to study those a little bit in I guess, grade 12, but definitely in college. But for most of what you deal with in high school, especially grade 10, you deal with functions that have a one-to-one correspondence. Am I making sense? Okay. So I have a video I want to show you, and if you're watching on YouTube, I linked the video in the description. All right. So you can click the link down below the video, and you'll see this other video made by a bunch of mathematicians to help explain this idea of putting something in and always getting the same thing out. Okay, so let's watch that.